Hello students, this is Dr. A.S. Ayyad. I welcome you all for the course on Finite Element Method in Civil Engineering. Our today's topic is shape functions for 9-noded rectangular element using Lagrange's Interpolation Function. Already in the last class we have solved the 4-noded rectangular element by using Lagrange's interpolation function. Using the same concept now, today we will discuss 9-noded rectangular element. So if you consider 9-noded rectangular element in natural coordinate system, using the same concept, we know that in natural coordinate system, the maximum ordinate is +1 and minimum ordinate is -1. So if you see here, it is a 9-noded rectangular element with the 4 corner nodes, that is 1, 2, 3 and 4. So 4 corner nodes, then 4 middle nodes at the 4 edges of rectangle. This is 5, 6, 7, 8. And the last 9th node is assumed at the center of element, that is 9th node. Okay. We know that xi coordinate is positive towards right, so negative towards left, right? Then eta coordinate is plus vertically upward, so it is downward. It will be minus if it is vertically downward. Now coordinates of all nodes, we know that this first quadrant is with the plus sign, second quadrant is minus, third quadrant minus and fourth quadrant plus. These are the signs, we know that. So since it is a plus, the coordinate of node number 3 is 1, 1, right? Then since node number 1 is in the third quadrant with the minus sign, the coordinates will be -1, -1. Then coordinates of node number 4 are xi minus eta plus, so it is -1, 1. Coordinates of node number 2 are xi plus eta minus, it means 1, -1. So these are the coordinates of 4 corner nodes. Then we have to write down coordinates of middle nodes. So if you take example, first node number 5, it lies on eta axis. So if it is on the eta axis, means its xi coordinate will be 0 and eta coordinate will be -1 because vertically downward. Similarly, if you look at the node number 7, which is also on the eta axis, so xi coordinate is 0, eta coordinate is +1. Similarly, node number 6, it lies on xi axis, so eta coordinate will be 0 and xi coordinate will be +1 because it is towards right. And coordinate number or node number 8, it lies on xi axis, so eta coordinate is 0 and xi coordinate will be -1 because it is towards left, right? And since node number 9 is coincides with the origin of element, we know that in natural coordinate system, origin is always assumed at the center of element. So node number 9 is also assumed at the center of element. So node number 9 and origin are coincides, so its coordinate will be 0, 0. Okay, so these are the coordinates of all 9 nodes. Now we know that in Lagrange's interpolation function, when you apply to find out the shape functions, it is written like this: nk, where k stands for the node number for which you want to find out the shape functions, right? So it is a ratio of xi coordinate multiplied by ratio of eta coordinate. Already we have discussed this, how to use this polynomial in the 4-noded rectangular element. We have discussed in detail. So here now we will apply for this 9-noded rectangular element. So one by one. Now first, if you want to find out shape functions for the corner nodes. Corner nodes means node number 1, 2, 3, 4. Okay. So first shape function at node number 1. So if you consider the same rectangular element now. Now to apply the Lagrange's polynomial function, since we are writing for node number 1, right, we have to identify first the edges which are connecting at node number 1. These are the 2 edges, right? This edge represents the z direction and this edge represent the eta direction. Okay, so the remaining nodes in z direction are node number 5 and node number 2, right? These are the remaining nodes, means these will be the values of m one by one. So since we are writing shape function for node number 1, we know that k will be equal to 1. And now since there are two remaining nodes in z direction, first m will be equal to 5 and then m will be equal to 2, right? 2 and 5 are the values of m. So one by one, first we have to take the ratio of taking k equal to 1, m equal to 5, and then we have to take a ratio of k equal to 1, m equal to 2, right? So like this we have to find out the shape function for node number 1. So look at this, k equal to 1, so it will be n1. Now first m is equal to 5, right? So xi minus xi m means xi minus xi 5 divided by xi k means xi 1 minus xi m. Xi minus xi m divided by xi k minus xi m, k equal to 1, m equal to 5, right? Then for second remaining node is node number 2. Now we will take k equal to 1 and m equal to 2. So xi minus xi 2, this is value of m, xi minus xi 2 upon xi k minus xi 2, that is xi 1 minus xi 2, right? So this is first ratio, two ratios for the nodes remaining in z direction. Similarly, if you look at the nodes remaining in eta direction at node number 1, in eta direction there is node number 8 and node number 4. So we have to take m equal to 8, k equal to 1 in first combination, then k equal to 1 and m equal to 4 in the second combination. Okay, so if you take this, this is eta minus eta 4 because m equal to 4 and k is still k is equal to 1 because we are writing n1 only. So eta minus eta 4 upon eta 1 minus eta 4. Similarly, if you take m equal to 8, eta minus eta 8 divided by eta 1 minus eta 8, right? So like this we have to write down the shape function for node number 1. Then if you substitute the values of known coordinates, that is, this is xi 1, this is eta 1, then xi 5, then eta 5, coordinates of node number 5, this is xi 2 and eta 2, right? Similarly in vertical direction, this is xi 8, eta 8, and this is xi 4 and this is eta 4, right? So putting these values of xi 5, it means it is equal to 0. Here if you put xi 5 equal to 0, look at this. Then xi 1 is equal to minus 1. Here xi 1 equal to minus 1. Here xi 1 equal to minus 1. Then xi 2. Here xi 2. Xi coordinate of node number 2. Xi 2 is equal to plus 1. So here it is 1 1. Okay. This is the minus sign of this polynomial. Right. So like this, if you substitute eta 4, that is equal to 1. Eta 8, which is equal to 0. Then eta 1 is equal to minus 1. Like this, if you substitute all the values and if you simplify, you will get n1 is equal to this, right? This is value of shape function 1. Similarly, you can determine the shape functions of other three corner nodes like n2, n3 and n4, right? So shape function n2 will be equal to, so if you are talking about shape function 2 at node number 2, k will be equal to 2, right? K will be equal to 2. Then the remaining nodes in the z direction of node number 2 are 1 and 5, and in eta direction remaining nodes will be 3 and 6. That's why here 1 and 5 means here it is taken xi 5 and here it is taken xi 1, and since k equal to 2, here it is xi 2. So xi minus xi 5 divided by xi 2 minus xi 5, it is the first ratio. Then xi minus xi 1 divided by xi 2 minus xi 1, it is the second ratio. Similarly, in vertical direction of node number 2, remaining nodes are 3 and 6. So eta minus eta 6 upon eta 2 minus eta 6 into eta minus eta 3 upon eta 2 minus eta 3. Again, if you substitute all the known coordinates of node number 2, node number 5, node number 1, similarly node number 6 and node number 3. So if you substitute all these known coordinates here like this, you will get the shape function n2 is equal to this one. Okay. Similarly, we can write down the shape functions of node number 3. Right. Node number 3 now. If you look at here, node number 3 in z direction, just 1 minute. Yes. In node number 3, if you look at the z direction at node number 3, remaining nodes are 4 and 7. And in eta direction, remaining nodes are 6 and 2. Right. So in z direction, remaining nodes are 4, 7. So it is xi minus xi 7 upon xi 3 minus xi 7, because we are writing shape function for node number 3. K will be equal to 3. Right. So xi minus xi 7 upon xi 3 minus xi 7. Similarly, second remaining node in z direction is 4. So xi minus xi 4 upon xi 3 minus xi 4. If you look at the eta direction, remaining nodes are node number 6 and node number 2. So eta minus eta 6 upon eta 3 minus eta 6. Then eta minus eta 2 upon eta 3 minus eta 2. If you substitute values of xi 7, xi 4, eta 6, eta 2 and then xi 3 in these two ratios and eta 3 here two ratios by using the coordinates of node number 4, node number 7, node number 3, node number 6 and node number 2. These 5 coordinates of 5 nodes you have to use here. If you simplify, if you substitute and simplify, you will get the shape function at node number 3 is 1 plus xi into 1 plus eta into xi eta divided by 4. Right? Similarly, we can derive the shape functions of node number 4. So in node number 4, in z direction, the remaining nodes are, in z direction, remaining nodes are 7, 3, and in eta direction, remaining nodes are 8, 1. So in z direction, remaining nodes are 7, 3 means xi minus xi 7 upon xi 4 minus xi 7. It is xi 4 here because we are writing shape function for node number 4. So k will be equal to 4. So xi minus xi 7, xi 4 minus xi 7, similarly xi minus xi 3 divided by xi 4 minus xi 3. In eta direction, remaining nodes are 8 and 1. So eta minus eta 8 upon eta 4 minus eta 8. Similarly, eta minus eta 1 upon eta 4 upon eta 1. If you substitute all the coordinates of nodes, that is this node number 4, node number 7, 3, 8 and 1, will get the shape function for node number 4 is xi minus 1 into eta 1 plus eta into xi eta divided by 4. Okay, these are the shape functions for 4 corner nodes. Now if you look at the nature or similarities in these 4 shape functions, we can come to one important conclusion. If you look at, when we are writing for shape function 1, n1, if you look at the coordinates of node number 1, it is minus 1 means minus xi and minus eta. So that's why here 1 minus xi, 1 minus eta. And this is multiplication of again xi eta. If you multiply minus xi into minus eta, the multiplication will be plus. Right. So these two brackets are following the signs of these coordinates, as well as xi eta also following the signs of coordinates. So if you substitute these signs here, we can directly write down n1 instead of performing all this calculation. We'll see for node number 2 also. See, for node number 2, since xi is plus and eta is minus, it is 1 plus xi and 1 minus eta, first two brackets. Okay, this should be 1 minus eta first. Right. Now multiplication of these two, xi into minus eta, so it is minus xi eta, and because of this minus sign, this 1 minus eta becomes eta minus 1. Because of this minus sign, this 1 minus eta becomes eta minus 1. So shape function will be like this. We can also write the shape function like this: 1 plus xi, first bracket, then 1 minus eta, second bracket because of this plus 1 and minus 1. Then here we can write down xi into minus eta means xi into eta, and we can write down minus sign outside divided by 4, right? And because of this minus sign, this bracket becomes eta minus 1, right? Similarly, if you look at the node number 3, now since both the coordinates are plus plus, it is 1 plus xi, 1 plus eta, then multiplication of xi eta is again positive. Similarly, shape function for node number 4, it is minus xi quantity and plus eta. So it is 1 minus xi, 1 plus eta, 2 brackets. It is 1 minus xi first, and then multiplication of these two is minus xi into plus eta is minus xi eta, and because of this minus sign, this 1 minus xi becomes xi minus 1, right? So these are the shape functions for 4 corner nodes. Now we'll see how to derive the shape functions for 4 middle nodes. Okay, now middle nodes. So if you, so this is actually just we have discussed. In general, shape functions for corner nodes are given by, so as I said, these brackets, 2 brackets are following the signs of coordinates because this 1 plus xi into xi k. So if you multiply the coordinate of that node, xi coordinate of that node and eta coordinate of that node, you will get those 2 brackets. Similarly here, if you multiply those signs for the xi and eta, so you will get directly shape functions of 4 corner nodes instead of performing the calculation of polynomial, right? Now corner nodes, shape functions for middle nodes, right? Node number 5, 6, 7, 8. So first shape functions for node number 5. Now if you look at node number 5, right, which are the nodes remaining in z direction? So in z direction, if you look at, there are 2 on the either side of middle node 5. Remaining node is 2 here on the right side and node number 1 on the left hand side. So remaining nodes in z direction are 1 and 2. Okay, so and similarly in eta direction, eta means vertical direction, if you look at, the remaining nodes are 9 and 7, right? So if you look at that polynomial, in z direction remaining nodes are 1 and 2, so it is xi minus xi 1 upon xi 5 minus xi 1. Similarly, xi minus xi 2 upon xi 5 minus xi 2. So xi 1 and 2 are the remaining nodes in z direction. Similarly, in eta direction, remaining nodes are 9 and 7. So eta minus eta 9 upon eta 5 minus eta 9. Similarly, eta minus eta 7 upon eta 5 minus eta 7. So eta 5 and xi 5, it means we are writing for shape function node number 5, so k will be equal to 5. If you substitute the coordinates of node number 1, 5, 2, 9 and 7 here, all these required coordinates, and if you simplify that, you will get like this: 1 minus xi square into eta minus 1 into eta divided by 2. Similarly, if you want to find out shape functions for node number 6, okay, 7 or 8. Suppose if you want to find out shape function for node number 6, right? So what are the remaining nodes in z direction? In z direction, remaining nodes are 8 and 9. Okay, so it will be xi minus xi 8 upon xi 6 minus xi 8 into xi minus xi 9 divided by xi 6 minus xi 9. Similarly, in eta direction of node number 6, the remaining nodes are node number 3 and node number 2, right? So it will be eta minus eta 3 upon eta 6 minus eta 3 multiplied by eta minus eta 2 divided by eta 6 upon eta 2. If you put the coordinates of all these nodes in that polynomial, you will get n6 is equal to 1 plus xi into 1 minus eta square into xi divided by 2. With the similar process, if you want to find out shape function for node number 7, the remaining nodes in z direction are 4 and 3, and in eta direction are 9 and 6. Again, if you use Lagrange's polynomial, you will get n7 is equal to this. And for node number 8, The remaining nodes in z direction are 9 and 6, and remaining node in eta direction are on either side it is 4 and 1. So if you put all the coordinates and use that polynomial, this will be the shape function at the node number 8. Then in general we can write down the shape functions for middle nodes using this formula. See, the nodes which are on the axis of xi equal to 0 means for 8 number node and 6 number node we can write down shape function like this. K is equal to 8 or k is equal to 6, n8 or n6. So 1 minus xi square 1 plus eta into eta k. It means if you are writing for shape function for node number 6, that is n6, here we have to consider eta coordinate of node number 6. Similarly here you have to write down eta k, that is eta coordinates of node number 6. Okay. Similarly here, if the nodes which are on the eta axis means node number 5 and 7, for that we can use this formula to write down the shape function directly. Okay. Otherwise, using the previous calculation in detail, we can write down the shape functions of middle nodes. Right. The last node remaining is now the corner nodes, central node. So that is only one node central, that is node number 9. Right. So which are the remaining nodes in xi direction? If you look at, on towards right it is node number 6, and towards left it is node number 8. On the upward in eta direction remaining node is node number 7, and in downward direction remaining node is node number 5. So in z direction remaining nodes are 8 and 6. So it will be xi minus xi6 upon xi9 minus xi6, xi minus xi8 upon xi9 minus xi8. Right? We are writing for k equal to 9, it is n9. And in eta direction remaining nodes are 5, 7. So eta minus eta 7 upon eta 9 minus eta 7, and eta minus eta 5 upon eta 9 minus eta 5. If you substitute all the coordinates here and if you simplify, you will get shape function of central node will be 1 minus xi square into 1 minus eta square. Right? So this is the shape function for 9-noded rectangular element using Lagrange's interpolation function. I hope all of you understand how to apply Lagrange's interpolation function to find out shape functions for 4-noded rectangular element, 9-noded rectangular element. Also in the previous videos we had discussed 2-noded bar element and 3-noded bar element. Okay, thank you very much.